In this video, we'll be talking about the acceleration due to gravity. In our last video, we calculated the force between you and the Earth, which means that it's also the force between the Earth and you. And the number we got for a 60 kilogram person was a force of gravity of 587 newtons. And that means that the Earth is pulling you down at 587 newtons, and you're pulling the Earth up at 587 newtons. And then when we calculated the acceleration, right, so we said this is the force of gravity, but force is mass times acceleration. So acceleration is force divided by mass. So when we got that 587 newtons and we divided by the different masses, so for you, so this acceleration due to gravity, I'll put a little g there. For you was 587 newtons divided by 60 kilograms. The number we got there was about 9.81 meters per second squared. So for you, you were accelerating towards the Earth at 9.81 meters per second squared because of this force. And the number we got for the Earth was much smaller. So the cool thing is that no matter what object is on the surface of Earth, they will all have the same acceleration due to gravity towards the Earth. So that means if I have, say I have a very large person, wow, they have very long legs apparently. Okay, maybe they're on stilts. Okay, they're on stilts. They're a clown. Okay. And so say this clown has a mass of 120 kilograms. Well, if we look back at the equation for gravity, Fg equals big G m1 m2 over r squared. And m2 is the mass of Earth. And r is the distance from the center of Earth to the surface, which in this case, right, is the radius. That this clown, because it has a higher mass, this m1 is a bigger number, will have a stronger force of gravity pulling down on it towards the Earth. And that's absolutely true. So when you plug that number in, you're actually going to get twice as much as the force on the 60 kilogram person. Right? And you can do that calculation by yourself just to verify. But for this person, the force of gravity would be twice 587 newtons. So that's 1,174 newtons. Right? So much larger force. But if you want to find out the acceleration due to gravity, they'll actually come out to the same. So if we do 1,000, so we're finding the acceleration due to gravity, which is the force over the mass. So 1,174 newtons divided by 120 kilograms, come out with the exact same number, something that's just about 9.81 meters per second squared. How does that work? Well, remember, what we're doing here is kind of a two-step problem. We're finding the force using this equation, Newton's equation, and then we're finding acceleration using Newton's other equation. And if I just substitute these in, right, and remember this mass down here on the acceleration equation is the mass of the person, so we'll call that mass 1, and mass 2 will be the mass of the Earth. And we just, instead of writing F, we just write out this whole thing, gm1 m2 over r squared, which is F, and then that divided by mass 1 should give us our acceleration due to gravity. Well, look, mass 1 cancels out with itself. So when you simplify it, all you get is big G times m2 over r squared. So we have the universal constant of gravitation times the mass of the Earth divided by the radius of the Earth squared. And these numbers don't change depending on, what object we have as mass 1. It doesn't matter. So we always are going to get that number that's about 9.81 meters